Okay, so this is the edge finding demo, and I have a document. It's a double-sided document that you should have received. It's also available digitally, and it has some instructions with some pictures, and on the back side it has written edge finder instructions, and I'm going to go through this side of it. And this is basically the same thing, but it's good for reference, especially when you're doing this, any edge finding. You're going to want to kind of reference this document for a few times during the semester for any time that you're seeking a location, like to do a whole location. A lot of times when you're doing an overall length, you'll see in another later demo on this particular project, the last thing we do is we can actually just measure and use the existing micrometer dials to zero and get the lengths we need. But when we're going to a location within the middle of the material, we would need to use the edge finder. So I have secured the workpiece. I'm going to go off again off the written directions here. I've secured the workpiece, made sure that this was a clean, perpendicular and parallel setup. I have mounted the drill chuck in the milling machine spindle. And number 3, it says clamp the edge finder in the drill chuck hand tight. I actually do use the drill chuck key to make sure it's secure within the drill chuck. I don't have to torque it down like I would for a regular drill. When we're using any other drill within the drill chuck, we want to make sure it's good and tight, but we do want to use the drill chuck key to make sure this is more than just hand tight. So from here, I'm going to turn on the spindle. Actually, number 4, lower the quill at least 1 inch so the edge finder can clear over the top of the workpiece. So in this case, I'm edge finding and I have my material set up where this is the machined edge. On this edge, it's actually, I'm going to do it the other way. I'm going to take this out and I'm going to be edge finding from the middle. So this is clean. I'm going to take my hammer. Make sure that's sitting parallel on the vise. And I'm actually going to edge find on this side because if you notice on the drawing that I have here taped up underneath my digital readout, I don't know if you can see this, but I have this, my drawing here. I'm locating the Y down off of the solid jaw or the fixed jaw in the back. The X datum is not going to be on this side, but it's actually going to be in the middle of the vise. So I'm actually going to take up my quill is taken up all the way. I'm going to bring my edge finder over on the other side of the part here. And then I'm going to bring this down and lock the quill, making sure that the top edge of the tip of the edge finder clears the top of the part. So that looks pretty good. So that's number 4. I'm going to lower the quill 1 inch. When I'm using the edge finder, you don't necessarily need to use the quill stop here. I can just use the quill lock to make sure I have the tip of the edge finder at the right location. I do want to leave at least 1 inch here of travel. So if I have to go on the other side, or I'm actually going to edge find from the back edge of the part here, I can easily bring the quill up and clear the part. So from here I'm going to go to number 5. I'm going to turn the spindle on and set it between 8 and 1,000 RPMs. When you run a CNC equipment, and even this equipment, make sure we're not starting the spindle too high. So I'm going to make sure I'm in low and release the emergency stop. I'm going to go forward. And I can keep my hand on the dial. I know I'm probably not going to go on the dial. I'm not going to go I'm not going to go too fast when I start, but I am going to keep my hand on the dial when I turn this spindle on. And, lower it a little bit as I turn it on. So now it's 1,000 RPM, so that's pretty good. So from here, I'm going to go to number 6. I'm going to use the table or this saddle crank. This is the table crank. This is the saddle crank. And I'm going to slowly move the workpiece towards the edge finder until the tip begins to run true. So I always start with the edge finder. Actually, I can just use my fingertip and make sure that it runs eccentric. And I can see that it's not running concentric. So as I bring my table closer to the edge finder actually will start to run concentric, and I'll see it, and that tells me that I'm on the tip of my edge finder is actually hitting the edge of my part. Okay, so I'm very close right now to seeing that that's concentric. 7, I'm going to continue moving slowly the workpiece towards the edge finder until the contact tip moves sideways. So for number 7, what I like to do at this point, I'm very close to concentric. So before I go on to number 7, I'm actually going to loosen my micrometer dial on my table travel, and I'm actually going to 0 this. And I'm going to lock the collar just finger tight right here. Okay? So from here, oh, you can't see that, can you? Again, I'm really close. I've done operation 6, and I'm going to make sure I 0 this collar, this micrometer dial on each of the table travels of axis. It has a little threaded collar here, so I'm going to rotate, unlock this by hand, set the 0 to the mark on the body of my table, and then I'm going to lock this so this is 0. So now from here on, I'm only going to go in one direction. If I go backwards and I feed in this direction, I would be bringing the material away from the edge finder, and there's backlash, and the 0 mark that I just set is not going to be accurate because there's probably about 5 to 10 thousandths backlash, which means the micrometer dial going in one direction and then changing directions, the micrometer dial will move before the table moves. So this wouldn't be accurate to the opposite direction we would be going if I were to change directions on the table feed. So every time I change directions on the table feed, I would need to either re-edge find or re-establish where the micrometer dial is set from. So in this case, I'm going to go clockwise on my handle dial, and it's spring-loaded, so if I go this way or this way, it's not engaged, my table travel doesn't move, I need to actually push the handle in, and I'm going to watch my edge finder because it is going to be kicked off of the edge of the part and run eccentric as I get to that edge. So I'm going to, what I like to do, I like to take my knuckles and just tap on this, and I'm moving about 1,000ths each time, and I'm watching my edge finder. Sometimes I might need to move my head and check the angle, so make sure I can see. Okay, so that, I moved it another 1,000ths, and that I can see it's eccentric off of the edge of the part. So the tip of the edge finder has hit the edge of the part, and now it's not running concentric with the spindle. So you'll see a little gap here between the shank of the edge finder and the tip of the edge finder. Okay? And on this dial it says 6,000. So I'm actually going to very carefully hold the micrometer dial, unlock the collar, and I'm going to set back to 0. Okay? That's number 8, set the micrometer dial to 0. Now, number 9, I'm going to back off the feed crank half rotation and repeat steps 6 and 7. So instead of going towards my edge finder, I'm going to back off, spring loaded one location, one half rotation, and then take up the backlash again. And I'm going to very gently knock, knock, knock. And now it does show 0. So that's step number 9. I actually take the backlash out by going a half a revolution backwards and then go back to dial back to 0 very carefully. And I can see that I went from running concentric to where now the tip is eccentric from the shank diameter of the edge finder. Number 10, at this point I'm going to raise the quill. I'm going to unlock the quill and raise this up. So the tip of the edge finder clears the top of the workpiece. And then I'm going to feed the workpiece towards the edge finder. So I'm going to go this direction, clockwise, towards the edge finder. The radius of the tip of the edge finder. I've measured this tip. Most tips are 200 thousandths. But you always want to make sure you measure the tip of the edge finder. I did measure this tip at 200 thousandths. So I'm going to go, the radius of that diameter is 100 thousandths. I'm going to go 100 thousandths on my micrometer dial, engaging the table feed. And then I'm going to do number 12 now, reset the micrometer dial to 0, making sure I'm holding the micrometer dial, loosening the micrometer dial nut with my hand. I'm going to rotate this to 0, and then relocking the collar of the nut here, holding the micrometer dial to the table trowel. That's 12. Now, 13. I'm going to feed the workpiece from the distance of the edge of the location or the dimension on the drawing. So through this process, what it is after I've reset the 0, after subtracting or moving the radius of the tip of the tool, that tells me that my spindle center line, exactly through this center, is exactly on this edge of the part. So my spindle center line is now on datum X, and I'm going to move to the first tool location. In this case, it's 312,000. This is again set at 0. So I'm going to go 1 rotation is 200 thousandths, reading the incremental units on the micrometer. And then another half rotation is 100 thousandths, so that's 300 thousandths. And then reading the units on the micrometer dial, I'm going to go another 12 thousandths. One line equals 1,000, so I went 312 lines on my micrometer dial. So now I've established that the spindle center line in this table direction from this edge, this spindle center line is established as 312 thousandths from this edge using the edge finder. So I can actually at this point lock the table. And this long, what we often refer to as X, but this is my longest table travel. There's 2 clamps here in the front near the way covers. So I can very gently clamp those. And now what I'm going to do is I'm going to edge find the same way, but I'm going to go with the saddle crank. I'm going to come over to here. I'm going to turn on my spindle. I'm going to bring this down so the tip of my edge finder doesn't hit the back jaw, but it does extend past the top of my part here. And then I'm going to make this run eccentric and again follow the steps in this direction, feeding this direction. The saddle cranks are not spring loaded, at least this one isn't. I think some of them, I know some of them are, but this particular saddle crank is not spring-loaded. So I'm going to get, again, really close. I'm going to reset this to 0. I'm going to watch very closely as I hit this with my knuckle, and I can see this is about 5 thousandths. I'm going to reset the 0. Lock the collar, back up 1 or half revolution, and then dial back to the 0. So that's perfect. I'm going to bring this up. I'm going to go from the 0, 100 thousandths. That represents the radius of the tip of the edge finder. I'm going to set back to 0. And then I'm going to look on my drawing, and on the Y datum from the solid jaw, I'm going to go 531 thousandths. That's going to be 1 revolution is 200 thousandths, 400 thousandths, 500 thousandths, and then another 31 thousandths. This is going to give me a location of 531 thousandths. Okay, and I'm going to lock this table travel, this saddle table travel on this left side. So from here, I can actually remove this. One of the first things you should do is go ahead and use your center drill, put your center drill in there, and bring the quill down, and check to see that the tip of the center drill, it would drill at the intersection of the 2 lines that you laid out. So again, we're using the layout with the scribe lines just to show that we are edge finding correctly. The back jaw, the Y datum, this inside edge should be the machine finished edge is the X datum. You should have laid that out correctly. This would be the sawed edge that's overhanging here. The other thing about this project is at this point, you don't have to edge find for the remaining holes. Going in this direction, I can just loosen the lock after I'm done with this drilling and tapping this hole. I can just look at this. I know I'm at 312. The next value I would go to is 781, so I would just continue on. So from here it would be 312, I would go to the next 0 would be 400, then 600, then another 100 thousandths, and then another 81 thousandths on the micrometer dial. And then I wouldn't be moving my table saddle crank from my current edge finding until I've gotten to this 5th hole. And then when you're doing, and it doesn't matter the order you go in, because as far as I could do these 5 holes going only in this direction on this table feed after I've done my edge finding, or I can do these 5 holes first. But when I go to a separate row on the saddle crank, because I'm going to be going actually on the table crank, either backwards, going from here back, I would actually re-edge find on either one of these holes, if I was either one of the sets of holes, as I would I want to keep traveling in the direction from the datum this direction instead of from the side edge in this direction. So I want to always make sure I'm traveling accurately on this cable travel moving this direction. So if I finish these 5 holes, then I would go back and edge find this edge, and start over for these 5 holes to make sure I'm always traveling in this direction in order to not travel opposite that and have backlash affect my accuracy.